All right. Okay, so again, this was actually the example. We didn't finish it, but we did start it last time. Okay. You know, basically here, as the example says, you want to be able to withdraw $30,000 each year for 25 years, okay? And your account earns 8% interest. So we want to know, excuse me, how much do you need in your account when you retire? You know, that's really the question now, right? How much do you need to have when you retire? Okay, so if I remember correctly, I think we solved this using, no, we didn't solve it using the formula, but we're going to solve it now using the formula, and then we'll solve it using the TVM solver, okay? All right, so here, okay, so here we have P sub 0, remember, right, from our formula. That's how much is in the account, you know, initially, okay? And that's what we want to figure out. You know, we want to know how much is in the account initially. That's what we're looking for, okay? That's what we want to figure out. All right, so that's what we're going to look for first. PMT, okay? That is our regular withdrawal, you know, how much we're taking out regularly, okay? It could, remember, in other cases, it stands for a monthly deposit. In this example, it's going to stand for monthly withdrawal, okay? That's what it's going to stand for. And in this case, we know that that's 30,000, not monthly, excuse me, it's regular withdrawal or regular deposit. Sorry, I apologize, I misspoke. Here, it's annual withdrawal. So in this case, it's $30,000. I know usually for us it was monthly deposit in the previous examples, if I remember correctly. Here it's $30,000. So now R is the annual, excuse me, R is the annual interest rate, you know, the APR. Here you write it as a decimal. You don't want it as a percent, so it's 0.08. And is how many times it's compounded in a year. So, you know, that's once a year here, as we're told. Mostly because, remember, we're assuming that it's compounded as often as we're making deposits or withdrawals. We're withdrawing money once a year, so it's compounded once a year. And T is how many years this is going on for. This is, so in this case, we get 25 years. Okay. Now, all right, so here, okay, this is our formula. Remember, we've seen this before. You know, it's in the notes, in the textbook, all that stuff. We have our variables. Let's fill them in. PMT we said is $30,000. We have 1 minus 1 plus R is 0.08. N is 1. N again is 1, right? That's what we said already. T is 25, okay? And we have 0.08 over 1. Now remember, when you're solving this, you want to always do the innermost parentheses first. That's what you want to solve first, okay? The innermost parentheses first. In the numerator and the denominator, you handle the numerator and denominator separately. So here we're going to do 1 plus 0.08 over 1, right? 0.08 over 1 is just 1. It's 0.08, excuse me. 0.0, you divide something by 1, you don't change anything. So we have 1 plus 0.08, we get 1.08, okay? The exponent, let's handle that next. That's negative 25. So we have this so far, okay? Okay, so now we want to do 1.08 raised to the negative 25. You know, you can use a calculator for that. I mean, I definitely would. You get 0.1460179. And again, normally I would tell you to how many decimal places to round to, okay? And normally for money, and generally it's going to be 2 decimal places. And here, notice I'm using more than 2. I'm actually using, it looks like 5. Okay, 5 or 6. I think here I'm actually using 7. No, excuse me, I misspoke. I'm using 7 decimal places here. You want to use more than 2, definitely, is what I'm saying. In intermediate calculations, I probably would use 4 at least. All right. So from here, we have 1 minus this. Then we do 30,000 times that over 0.08. And we calculate this difference because that's in parentheses, so that's first. Now we have all this. What do? Multiply and divide, we get this. $320,243.29. So I did round. So that's how much must be in the account initially. Okay? That's how much must be in the account initially. All right. Now we're going to solve this using the Tvm solver. So here, this is the same problem, of course. For FV, again, that's how much is going to be in the account after time has passed, after 25 years. Now here, since we're, it's a retirement account, in theory, we want nothing left. We want to go through all the money, is what I'm saying. Okay, you don't want to have anything left. You don't want to have money that you didn't use. Okay, so FV is 0. PMT, again, that's regular deposit or withdrawals. So it's $30,000. Notice this is actually positive because the money we're taking out for us, it's coming to us directly. So that's why it's positive. Capital I, as we know, is 8%, but you don't change it to a decimal. Excuse me. Capital N is little n times t, which is, again, which is 1 times t, which is how many times the account is compounded throughout the whole scenario, right? It's once a year, 25 years, so 1 times 25, which is 25. PV is what we're looking for. PV is how much is in the account now, in the present value. These two both equal each other, P/Y and C/Y. P/Y, I'm trying to remember. Oh, excuse me. It's equal to how many times the account is compounded. Okay, they both equal that. That's actually what C/Y is, how many times it's compounded in a year. And they're both equal to 1. Okay? If I remember correctly, P/Y is how many times you're either depositing or withdrawing money a year. But again, it's still 1 though. So with the Tvm solver, you do actually get the same answer. But let's just go through it just for fun. So here we go. Let me share the Tvm solver with you. So I gotta stop sharing this. Here it comes. So we're going to put in our data, right? Okay, so capital N, what's that equal to? Well, that's 1 times 25, which again is 25. We said I is 8%. PV, that's how much is in the, that's what we want because that's what we're looking for, right? We want to know how much has to be in the account, how much has to be in the account now. Okay, that's what we're looking for. That's what they're asking for. PMT we have is $30,000, and we're taking money out, so that's why it's positive. FV, we want that to be 0. Again, since it's a retirement account, in theory we want to go through all the money. Both of these are equal to 1. We're solving for PV. We get negative 320,000. Hold on, let me move over. $243.29. Again, it's negative. That's not a mistake. That just means it's a cash outflow, money going away from you. So in theory, you want that amount of money in the account. Okay? I mean, they consider that negative, maybe because it's not in your pocket or something. I don't know, but that's just what they do. But basically, we get the same answer, and that's really what should happen. Okay. All right. Okay, so we're going to move on to another loan formula, review of that. Are there any questions on this though? Okay. All right, so let's keep going then. So I gotta stop sharing this. I mean, I'm sure we're gonna use it again today, but let me get back to the notes because now we're gonna look at loans. Okay, so again, with loans, here it was more realistic in that you're not generally you're not gonna pay off a loan with just one payment. You're gonna have to make many payments. Payments on a regular schedule is what we're doing. That's what we're assuming. I mean, is that realistic? I want to say no, but again, that's what we're assuming here, that the payments are on a regular schedule, like every month, every year, every 3 months, that kind of thing. This is a formula, which is actually, I think it's the same as the payout annuity, very similar to that. And, P0 is the initial amount on the loan. In other words, it's the loan balance, how much you owe at the beginning. PMT is the loan payment, the payments that you're making monthly, yearly, whatever. R is the annual interest rate, that APR, as you can see. N is the number of compounding periods there are in 1 year. Okay. And T is how long the loan is, how long this is going on, time basically in years. And keep in mind, remember, as before, if the compounding frequency, if that's not explicitly stated, then we can assume the account, the loan, I guess that is, it's compounded as often as we make payments or deposits. Okay. All right. Okay, so here's this example, for instance. Let me just change the recording.